Good. All right. The art of transpiling, introduction to JSConvert. So my name is Jon Boynton. For those who don't know, I write web apps. I've been doing it for a while. Last 2 weeks ago, we did the art of transpiling JS to Python and beyond. And we went kind of in depth what transpiling was. We did some code examples. This week is a little different. We're going to take the JSConvert application that I mentioned at the end of the last talk, and we're going to explore how that works, how it transpiles, and more importantly, it's written in Python, which is why we're doing this in a Python group, because I'm hoping that some people might want to take advantage of that and maybe add some of their own rules to the transpiler. So first, I'm going to do a couple of little shout outs. I'd like to thank Pi Southwest Florida for inviting me here, and Nessa Paulson, and also for Joe Mead for standing in today. Thank you, Joe. I'd also like to thank Southwest Florida Coders for getting me to start this this series. So, and of course, Zarella is here tonight, so thank you, Zarella. Also like to mention Southwest Florida Tech. I've been a member of the Southwest Florida Regional Technology Partnership for a while. They were one of the original groups in the area that tried to build and foster a technology sector in the area. I'm also a first volunteer. Their mission is to inspire young people to pursue careers in STEM. And STEM leadership, and they do that by hosting robot competitions. If you have young kids or grandchildren who are interested in science, technology, education, or math, I recommend that you check out firstinspires.org. Okay, now for tonight's subject, Python. Wait. Okay, so I said in the intro for this meeting that I was going to explain how I ended up going from being a Java developer to a Python developer for this project. So I've been developing, writing software for over 35 years, but I've only been doing it professionally since the late 90s. And I started after I learned Java. Now, back then we wrote Java applets. One of my applets ended up getting ranked in the top 5% of the internet at the time, which landed me a couple of job offers. One of which I took, and I've been working professionally and as an entrepreneur writing software ever since. Now, right now, I'm working with my company, datamessenger.com, to develop a distributed database for IoT. So if you work with Raspberry Pi or you work with Arduino, you're probably going to love this database. However, the database is written in Java. Now, back when I started it, that wasn't a big deal. But since there's been a lot of development happening in other languages and on the internet, in browsers, we have to use JavaScript. So the application, which was developed with a server and a client, I decided, well, I'm going to rewrite the client in JavaScript, and that way it'll work in browsers. So I did that. It took a while. It took about 4 months to rewrite that code and to get it working properly. And then after I did that, I said, well, gee, now I have to do this in Python, because if you're working on Arduino or Raspberry Pi, you really want to be working with Python, not Java or JavaScript. And I thought, well, I don't know as much about Python as I did about JavaScript. So maybe I need a project to help me learn how to code better in Python. And I thought, well, why don't I build a transpiler that will transpile my JS to Python? And that's what I did. The result was JSConvert, an extendable open source transpiler written in 100% pure Python. If you're interested, this is the GitHub. You're more than welcome to go there to download it. It's under an Apache 2 license, so you can pretty much use it anywhere you want, even at work. What I'm going to do for the rest of this talk is I'm going to kind of demo JSConvert. We're going to show you some code, some Java code, JavaScript, I mean, and convert it into Python. And then we're going to go into the code of JSConvert and see how it works, and how you can actually write your own rules to transpile code from JavaScript to Python or any language you want using JSConvert. But first, I think I'm going to do a quick review on what transpiling is, if you did not see the previous talk. So what is transpiling? Here's a simple definition. It's translating source code between programming languages that operate at approximately the same level of abstraction. So you can think about TypeScript is transpiled to JavaScript, or Kotlin transpiled to Java. There, of course, are many other examples. Compiling is more compressing. You're taking a high level of abstraction and you're reducing it to a lower level of abstraction. Transcoding is actually a low level of abstraction to another low level, or usually bytecode for transcoding, like a GIF image to a JPEG is transcoding. Yeah. So why do we do transpiling? Here's some reasons: compatibility, extendability, reusability, and reliability. So if you have code written in a brand new form of JavaScript, you want to transpile it to an older version of JavaScript to be compatible with older browsers. And you would do this using Babel, and it's probably, you know, in your Webpack right now. You use it all the time. TypeScript is also, you know, transpiled to JavaScript for compatibility. Another reason is extendability. So if you go to AWS, if you're using their API, or you go to Stripe and you're using their API, you're going to have JavaScript options, Java options, C#, Python, Rust options. And they do that because they want as many people using their API as they can get. So they will transpile those different versions of code. Reusability, that's pretty obvious. You've written it in one language, you've got another project in another language, you've already solved the major problems, why not just reuse your code, right? Transpile it. And then reliability, if you've transpiled your code, you've already iterated on your design, you've already tested the API against the real world. We want to reuse that as much as we can so we can get that reliability in our new code that does the same thing in a different language. Okay, so I asked this question, is all transpiling the same? And it's not really. I look at it, there's kind of like machine interpretability and human interpretability. In the South, I'd say interpretability. If you think about Babel, Babel does not care what the code looks like. It just wants it to work. So it'll take your JavaScript and it will make it work really well in an old browser, but it's going to be ugly. It's going to rewrite the variables. It's going to add in polyfills. It's going to move the code around. It's not going to look the same. I like human interpretability, because if I want people to use my API, if I want people to use my Python version and they've already used the JavaScript version, I want it to be an easy thing for them to do. I want it to look familiar. So I transpile for human interpretability. So we keep the structure, the general idea of the original code when we rewrite it in the new language. Obviously, you can't keep it perfectly the same, but the goal is to make it look very similar. So that would be human interpretability. So that's what JSConvert is designed to do. It's designed to take JavaScript, transpile it into Python, and do it in a way that still looks like the original code. So if you're familiar with it in one language, you would still be somewhat familiar in the other language as well. Now, to use JSConvert, there's some pretty easy functions that are built into the transpiler module. I can't get much more simpler than calling the function convert with the file. Let me get a laser pointer here. So convert, and then you just drop in the file that you want to convert. Optional file out, otherwise we'll just use the same folder and change the extension. Default rules, convert with Python, and DOM here. Now, format code, another simple function. You just go transpiler, your format code, you drop in your JavaScript source code, and the output is a string in Python. Pretty simple. I'm going to talk about what a DOM is here in just a minute. Here's some other modules. If you really want to get into writing your own code, these are modules you're going to have to familiarize yourself with. The transpiler module is really the big one. It has all the main classes in it. Comp and lang are used to actually model the JavaScript. So you'll look at them, but you won't necessarily want to extend them very much. And then there's rule packages. So I have a JS rules package that has modules that transpile JavaScript to JavaScript. You say, why would you do that? Well, you do that for testing. If you can't transpile it to JavaScript, you're probably not going to be able to transpile it to anything else. You can also do it for backward compatibility like Babel does, or you can do it for refactoring. If you have a JavaScript project and you want to refactor some of your code, you can just write a couple of rules and it will refactor all that code for you. Pi rules exactly is the same thing. You've got rules that are just for transpiling JavaScript to Python. And of course, I added a command line tool. If you don't want to write anything, you just have some JavaScript. You say, I want Python. This is the command tool. So I'm going to stop the PowerPoint here, and I'm going to get into doing a source code example. I'm going to show an example piece of JavaScript, and then we're going to open up the command line tool and convert it. I have to share a new, excuse me. Okay. Now, people who saw the talk 2 weeks ago might recognize this. This is I'm going to make this a little bigger here. This is a sample program that takes a couple of numbers, and it turns it into a string of words. So 101 would become 101. Now, this is a common example that is used throughout the internet, but most of those examples only went to like 1 billion. And as I told people last time, I remember from first grade that the number line went way past 1 billion. So I decided that this should go to 999 vigintillion. So we can get a really big number in there. And for people who don't recall first grade mathematics, vigintillion is 1 followed by 63 zeros. Pretty big number. Anyway, how this works really isn't too important. I'm just going to breeze through it. Up here, you see, is this being shared right? Okay. Up here, you see, I'm declaring an array called small numbers, and it has all my small numbers. And here I declare another array, constant array of large numbers. Down here, I'm creating a class called number string, and here's a constructor. If you only know Python, you would know this as an init, the init function or method. Down here is another method that splits the string into small numbers, 0 to 999. Also, I refer to procedural code inside the class as a method. Outside of the class, I call it a function. So I'll try not to get that confused. Sometimes helps out. Here's a method that just takes that small number and writes it out. And then here's a toString method that takes all those little tokens and adds the big words to them and does an output. Now, down here is a number that I'm going to try to output. Here's creating an instance of the number string class, and then I'm just going to log it to the output. So this should run right off this. Right in the node. Right, and there it is. The output is 431 quintillion 541 quadrillion 56 trillion 545 billion 3,102,000. Okay, now I need you guys to remember that number for later. No, any takers? No. Now I want to transpile this JavaScript into Python. So what I'm going to do, and hopefully this will share out okay. I'm going to stop sharing for a second. And I'm going to open up my command line. Let's see. I'm trying to bring it back to share. Yeah. Do X? Wait. Lost the app.
Right here.
Yeah.
Open. I think you have to open. Go click on this one. Click on the little window. Yeah.
Okay, got it back. All right, so I'm just going to go to my command prompt. I'm going to do a change directory, and I've cheated here. I've copied this. Just going to change the directory to where the JSConvert module is, and then I'm going to run Python on that module. And there it goes. Now all I need to do is type in the file I want to convert. Oh. It's going to ask me if I want to change the file output. I don't. I'll just put it in the same file. It's going to ask me if I want to convert, change the convert rules. I don't. I'm going to use the default. Then it's going to ask me if I want to print out a DOM model, and I do. So I'm just going to put yes. And there it is. It worked that fast. So that's still being shared.
Sharing the terminal.
What's that?
Sharing the terminal.
Sharing the terminal. So okay.
I think it's easy to share the entire desktop sharing and just share your entire screen.
Yeah. Where's the share the entire screen?
Desktop sharing.
Screen.
No, what it says is yeah.
Okay. So I'm sharing the whole screen. Okay. Let's get some of this stuff out of the way. And I'm going to refresh this. Okay, so there's the file. Anybody still there? There's the file that we created. Numbers to words.py. And we also created numbers to words.dom. So I'm going to open up the Python and we're going to see, compare these side by side. Trying to get these closer in size. Okay, so if you see up here, here's that number array being declared. Here it is up here again, but in Python, we don't have the const, so it's not there. If we look back down here at the class number string, it looks similar, but it's now Pythonic, right? And then here, where we had the constructor in JavaScript, we now have init, def init. You'll also notice that it dropped in the self. So if you're new to Python, you don't know what self is. Self is, instead of using this, Python uses self to refer to the instance of the object. So over here you see this, and then all those thises have been changed to self. And pretty much most of this is, if you look at it, it's pretty Pythonic. There's a couple of little errors here and there where the transpiler just didn't know what to do. There's one error in here right there where it had a regular expression over here, and it didn't quite know what to do with that regular expression, so it just didn't do anything. But one of the advantages of transpiling this way is that you can compare apples and apples rather than apples and oranges. So let's see if I can get back into my presentation. Okay, so how does it work? How does it know how to take that JavaScript and turn it into Python? It works by parsing the JavaScript into a document object model and then applies formatting rules based on patterns within the model. So what does that mean? So over here, you'll see our source code. Here is, for example, a comment, and over here in the document object model, there is a comment tag. Now, this tag is not XML. It looks like XML. It is not a JavaScript document object model. It is a JSConvert document object model. So each of these names within the tags refer to class files or subclasses of what are called a code entry, which is an object in JSConvert. So com represents a class in that encapsulates this particular comment. Const declaration is actually a class that encapsulates just this constant right here, this declaration. Assignment refers to this entire block. It's being assigned to this variable. Operator, of course, just refers to that operator. Expression refers to everything within that operator, the scope of that operator. So you can see from this document object model that it really models the structure of the JavaScript. It is not an actual programming language. You can't run this. It doesn't have you can't hack it, turn it into a bug or a virus. It just models the structure. Now, how is this useful? So you take something like the const small numbers array, and you break it down into its you break it down into a signature where you have const assign operator expression type. Let me back up one. If you look at all of this, there's the const assign operator expression type. If you think about a string and how you find a substring in a string, you have a string of characters, and then you search through that string. As soon as you find the first characters that match, it returns the index of where it matched it. This is doing the same thing, except instead of characters, it's looking for classes. This DOM is a continuous string of classes. It starts at the top left of the code and ends up at the bottom right of the code. So the transpiler just goes from one element to the next all the way down. And at each step, it looks for a pattern that was supplied by a rule. So in the case here, we're looking for a const array. There's our pattern, and then we're going to supply this pattern to our rule. In this case, we see the word const. The actual class is called const, but if I called it const, that would obviously have a problem in some versions. So I always prefix it with KW underscore. So, but the class here would be called const, KW underscore class or const. Assignment, operator, these are all the same class names that I use. Now, those classes are make up components, subclasses, use model language elements, and keywords within the language. So the entire DOM is made of those components or keywords. And here's a list of each. If you want to take a quick look while I get a sip of water. As you see at the top, there's the array type, there's the assignment, some other ones in there, like variable type and string type would make sense within the context of JavaScript. Keywords make sense in the terms of what keywords are being supported here. There are some other keywords supported, but these are the ones that actually have concrete classes in JSConvert. The next major element is a code buffer, and that's where all the magic really happens. Code buffer accumulates transpiled source code. So as the transpiler is moving along, going down that DOM, it looks for rules, and then it hands a code buffer to the rule, and the rule then applies itself based upon what the code buffer says. So the code buffer has a pointer to where the transpiling is at any given time. The rule then looks at that pointer. It gets the code entry that is matched to it. It evaluates and says, is this the entry that my rule is actually supposed to apply to? And then it will update the code buffer by putting in some string if it decides that the rule should be applied. If it doesn't decide the rule should be applied, then the transpiler simply proceeds with transpiling to the next rule that has a match. And here's some methods inside the code buffer. I'm not going to go too much into depth, but you might be able to imagine that one of the methods is transpile. So the code buffer, we pass in our source, we pass in some rules, and then we call transpile, and then we get a list of strings. And that list of strings is then joined together to make the final product. I did it that way because when you break it into strings, you can go back and you can kind of figure out what the transpiler has added and where, and it's already tokenized. So I didn't want to make it a string. I didn't want to concatenate a string. It made it easier to do as a list. this method here, current. So if you have a code buffer and you call current, it'll give you the code entry that the transpiler is at currently, right? The offset, if you say 1, current 1, it'll give you the current entry plus 1, current entry plus 2, and so on. You can go backwards as well. Next and previous are just easy ways to do that. The other main thing that code buffer does is you add a token to it. So when your code buffer rule decides that this is a rule I'm going to apply, it adds a token. It can add a new line, it can add spaces, it can do trimming, it can peek at the last token that was added, which is useful. You can also have sub buffers. So your code buffer starts out as being the entire body of work, but you can have sub buffers within that that you can use to do additional transpiling. You can insert code into the buffer. Even if it's already been written into the buffer, you can insert prefixes, and we'll show you that in example in just a minute. Code rule, this is the actual thing that you would write that makes the whole thing work. You have an init method where you pass in the name of your rule, and this is where you put in your path. We talked about that earlier with just a list of class names that you want to match the pattern. And then you would override this method here, apply. The apply method, if the path is matched by the transpiler, it will pass in the buffer. At that point, you can get the code entry at where the rule is supposed to be applied and the offset for the end of your pattern. And of course, all the rules go into a rule bucket, and the top rule bucket is the rule manager. It has an add method. It's really the only one you need to concern yourself with. It's generally populated automatically, but you can add to it yourself if you want. The any pattern is just kind of a wild card. I'm not really going to go into that right now, but sometimes a pattern, say you wanted to match an entire array and send it and make that a rule. If you don't know the length of the array, it's kind of hard to figure out what all the elements are. So any will ignore any component in that array and only match the child element that matches, say this, in this case, the array end. So it would match this pattern because it sees an array type, it can skip over all these, and it sees an array end. So that would match in a rule. Okay, let's code. Why are they giving me that one? Hey, there it is. Okay. Okay, so you're familiar with the JS and the Python version of our test code here. I said earlier that there were a couple of problems when we transpiled. One of the problems, if you look over here, is this, where it says spec.length. If spec is a string in JavaScript, length, of course, gives you the length of that string. Well, if you try that in Python, that is an error, right? So if you want the length of your string, you would have to do this. You would use your built-in function length to get the length of your string. Now, as it turns out, I used length a lot in this thing. So there's another one down there. There's another one there. There's another one there. If I were transpiling a lot of code, it would be a hassle for me to do this and just go through and change all these. So let's write a rule that will transpile this code. Okay. So what I'm going to do is I'm going to go to my Python package, and I'm going to create a rule module. I'm just going to call it demo rules. Now, in order for my demo rules to be loaded automatically, I have to add it to my init module in my PyRules package. So I'm just going to add it in here. And that way it'll look in that module automatically, and it'll ingest whatever rules I tell it to in there. Now here in my demo rules module, first thing I want to do is I need to import my code rule class, because that's the one I have to subclass. So I'm just going to go from and that one is in my transpiler module. Like I said, a lot of stuff is in the transpiler module. And then of course, just go from import from there, and I'm going to get my code rule. Now I'm going to create a class, and we're going to call this length to len, right? Because we're going to take a length off of our substring, or of our string, and we're going to put a len in front of it. And we're going to extend code rule. So all of our rules extend code rule. Then I'm going to create an init function. So I'm going to define my init. Now, I really don't have to pass any variables in here. The transpiler isn't going to call any of them. It's going to load it with an empty argument. What I do have to do is use my super to call the super class and pass in to the init a name of this class that a coding tool could use to give us an error or something like that. So I'm just going to call it length to len, right? That's a good name. Now I have to give it a path, something to match my code. To do this, we're going to have to do a little detective work. We're going to look at our DOM. This is a document object model that I printed out when I did the file. It's optional. You don't have to print this out every time, but I printed it out in this case. And when we look down and try to find where our length is, say if I just do a quick search for length, here's a match. Here, let me make this a little bigger. So here's a match, and it says variable type is our spec, and then it says variable type is our length. So I now have two variable types. That's kind of a pattern. And if I look down here, I can see that pattern repeat itself. Here again, find a good example. There it is, variable type and then variable type. So that's creating a pattern. So that's going to be a pattern that I want to use with my rule. I'm going to have to do some additional testing once that rule is matched, but this is a good place to start. Does this make sense? Okay. So I'm going to use my variable type class as part of my pattern, and I'm going to use two of them. So I'll just write this in here. Variable type. Variable type. And I'm going to pass that in as a list. Python has lists. If you work with JavaScript, JavaScript has arrays, right? But a list is basically the same thing. Yeah. Now I need to define my apply method. And this is the method that the code is going to, the code buffer, or excuse me, the rule manager, when it's going through the transpiler, it's going to say, hey, we found a match. Let's call the apply method of this rule. And if the apply method returns a 0, it means it did not apply anything and to continue trying to match. If it returns some number, it will say, okay, we have applied this number of classes in the DOM, and it'll advance the pointer to those next classes and then start matching again. So what I need here is a nice little test that will tell me when is this spec and length supposed to be applied to that rule. Now, the easiest one to look at is it's got to say length, and it's got to be at the end of that variable. So there's going to be a variable spec, variable length. So that's the rule that I'm going to use here. I can use, let's see, oops. So the first thing I want to do is I want to get my variable type. I want to get a reference to that element, or to the code entry. I know that I could call I'm going to bridge this to buff instead of buffer. I could go buff.current, and that's going to give me this entry. But what I really want is this entry here. So I can use my offset, and that's always going to give me the last entry, because it's going to add that number, whatever it is, to the current. And it's always going to be the last entry. I could also use .next in this case, or I could just use 1 instead of offset. And then I want to test that. So I'm going to say if c dot is, and I've got this method in here. It's one of the code entry methods, leaf. That'll tell me if it's the last one in a sequence. And then I'll say and c dot, oops, dot name equals length. So now I've got my apply method. It's already been called, and now I'm testing those code entries to see if they should be applied. And I said, yeah, it's a leaf, and yeah, it says length. So I'm just going to go to my buffer. I'm going to say I want to add my code, which would be in this case length, open parentheses, and then I want to add to my buffer the name, but I want to add the name of this variable here, not this one. So in this case, I'm just going to go add, oops, hey, thank you, Disney Plus. Add buffer dot current. And then I'm going to use the name. And that'll give me the name of whatever that buffer is. And then finally, I'm just going to go buffer dot add my closing part. And in this case, I have applied my rule to two elements in the document object model. So I'm going to return 2. If the rule failed, I would return 0. And that would instruct the transpiler to continue on with the next rule it can match to. Okay, so links dot variable. Now I've had one more detail up here. My module needs to have an all variable declared. And this is going to tell the transpiler that this is a rule that I need to load along with the transpiler. So I'm just going to put the name of it in there. The name of the class, and that'll tell it to load. This is handy if you have several rules and you want to do like A/B testing. You don't want to have to erase your code or comment it out. You can just remove it from the all. Okay, now let's run our transpiler again. This time I'm going to use PyTest. This is a very simple script. Here I've imported my transpiler as trans, and I've got trans.convert, and I'm passing in the file of my JavaScript. And I'm just going to run this by going like, run this as Python. Okay, and it did it. No errors. Now I'm going to reload this, place my contents in my editor, and look, there we are, length spec. Length spec. So it applied my rule. And if you look down here, it applied it fairly well until we got to here. If you can look at that, you might see there's a problem. It's got self.length.spec. Length is supposed to be a function by itself. So the rule was good, but it wasn't good enough. It should be length put in front of the self. So it should be self.value, right? So let's go back to the rule. And we're going to apply a different part of the code buffer. We're going to use something called insert, insert prefix. And then we're just going to put our length code as a prefix. Now, what this is going to do is it's going to take that current code entry, and it's going to say, hey, this is extending some other variable. Let's go up the stack to see where that variable starts, and then we will insert wherever it starts, right? Which works pretty good. It's not flawless, but it works pretty good. And it's a good way that if you have to put something in the beginning of a variable that may have 2 or 3 or 4 dots in it, just insert it. There is one problem with it, and that is, in this case, there is a self, and self was converted from this. Okay, doesn't sound like a problem, but it's already in the buffer. And the way this code works is it searches backwards for the name of the variable. And the name of the variable that it's going to be looking for is this. It's not going to find it because it's already been converted to self. So I have a little hack in here where we can use a dictionary to say this is the same as self. And that should be better. Oops. Wrong place. Okay. And the last thing I'm going to do here is insert prefix doesn't always work. So when I designed it, I said, well, let's return true if it works, and let's return false if it does not. So in this case, if it did not work, what would happen? It would write the name and it would put this parentheses, and it would be another mistake, right? So I'm going to take my insert prefix and I'm going to put it into my condition. So if it returns true, then I'm going to do the rest of this. If it doesn't return true, I'm just going to continue on like nothing happened and say this rule doesn't apply. So it's not a perfect solution, but it will generate good code rather than broken code. Now what we have to do is see if this is going to work. PyTest. And it ran. So let's go see if that handled that problem. Okay, so there is length spec, that still works. Length spec still works. And there we are, length self.value. That's what we wanted. And it has worked pretty much all the way down. So I'm happy with that result. We could possibly do more to this rule to make it a little more robust, but that's a pretty good result. It's a pretty good result. And it seems to have worked all the way down. It even worked on arrays. Python arrays are called lists. They don't have length either, but in JavaScript they have a dot length, so it worked on that as well. So the last thing to do here is let's see if we can actually get this thing to run. Like I said, it had a couple of problems. I know it has this problem where it had a regular expression, and that fixes that. And it has this problem here. There is no minus minus increment in Python, so you just go like this, minus equals 1, does the same thing in this context. The final thing that's wrong down here is I don't have a good rule for for loops. If you really want a nice project to challenge yourself, write some rules for doing for loops. I would love to have them. So we're just going to take our I, and in Python we just go in, and you guys are familiar with this, range. And my range is going to be the length of my array here. That should fix that. And the last problem I have down here, I don't know why this dot is here. This console.log. I don't have a rule that recognizes console.log. If you use JavaScript, you know that that's how you do your output. It's your favorite two word, console.log. In Python, they make it really hard. They just say print. Right? So here is our big number. Let's see what happens. Code. Oh, 431 quintillion, 541 quadrillion, 56 trillion, 545 billion, 3,102. So, and yeah, so is that the number you guys remember? Okay. All right. So we could do more rules. You know, there's an infinite number of rules. JSConvert does not dive into libraries. It doesn't do introspection of variables, things that I'd love to add at some point. But right now it's a very good tool for just doing this, taking script that's written and keeping the style and the intent of the author who wrote that script in the transpiled script, so that someone who learns one can learn the other one fairly quickly. That's it. Any questions? I mean, is it anything making not making sense here?
Really interesting. I'm curious as to the whole concept of transpiling. You know, how having never come across it in a while myself, have you seen it before?
Well, I've been using transpiler code for a while without realizing it. You know, I used to read a lot of JavaScript when I was doing web development with React and such. And a lot of the examples were in JavaScript, and they always have a TypeScript file and a JavaScript file. Well, it didn't occur to me, well, they were writing it in TypeScript. They weren't writing it in JavaScript. So the JavaScript examples always seemed a little harder than they needed to be. You know, they went a little bit further than I would have gone as a developer. And I realized, oh, these are transpile. But I was able to look at that code. I was able to understand it and understand what it was doing. So that was my first introduction to you know, commercial scale transpiling. I've been transpiling my own code just here and there, just because I wrote something in one language and wanted to use a similar algorithm in another language. Used to do that quite a bit, especially if you're writing in JavaScript. You'll find an example written in C, you know, or you C# and say, that's a good example, it's a good solution, but it's not in JavaScript. So you have to transpile it to get it to work. So you probably have been doing transpiling without really saying, hey, this is transpile.
It seems like transpiling could be really good for making efficient code if you transpiled from an uncompiled language into a compiled one.
Yes. So if you, I mean, if you look at Python, Python actually compiles itself into CPython, which is not C the language, it's C as in compiled Python, but it's more of a byte code and it becomes more efficient. But it's not its ultimate form. Its ultimate form is a machine language, you know, or assembly. So transpiling can make it more efficient, but I find that in my code that I'm doing, if I really want to be faithful to the original design, sometimes I have to overlook some of the efficiencies that I could take advantage of. You know, in some cases, it makes sense to just, you know, do away with the old pattern. But if it really ruins the initial pattern, I'm going to be a little bit less efficient when I transpile, not more efficient.
That makes sense.
All right. How am I doing on time? Oops.
Is it your goal with this project to release Python modules for Internet of Things abilities?
Well, like I say, the reason I originally did JSConvert is because I wanted to amp up my skills in Python. I had to write a client software for my database project in Python, and I didn't like the transpilers that were out there. There was transpilers like JS2Py, which kind of has its own JavaScript engine. Works good, didn't work really well with ES6. It was kind of experimental with ES6, which means it didn't work. Right? So, and there were earlier versions that just didn't do classes. So I really needed to do classes. Same problem with Java to JavaScript. Google had a project called, I think J2CL, I think, which was just getting started. It wasn't really developed, so I ended up doing my own solution there. I would have probably used it, but those solutions, again, they're transpiling to make it work perfectly. They don't really care as much about what it looks like in the end result. And what I want to do, like I said, in my project is I want to have like AWS. If you go to AWS, you're using one of their APIs. If you use the Java API, it's going to look different from the JavaScript API, but it's going to share a lot of the same functions or methods. A lot of the same naming conventions are going to be there, and I wanted to preserve that. I didn't want someone to have to learn that twice. You know, I found that myself. I've invested in certain APIs and languages, and then had to move over and, hey, this is completely different. You know, I'm saving nothing, right? So I didn't want that to be an experience. And that's the reason I wrote JSConvert. It started as an exercise. I don't have a team of 10 or 15 people that I could put on this for a year and say, let's build V8 version 2. So I said, well, what's the easiest way to do it? And I said, by putting in these ways to look at the patterns and just do replacement on patterns was the easiest way to do it. Once I started down that path, I realized I could actually just create a simple rule class that could hold that pattern, and then I could just add rules. I mean, anytime I found something new, I could say, hey, I could do this. I could put it into this link thing. I'll just create a rule for that. So every time I'd look at my code and I'd find something that it didn't transpile, I'd just say, oh, write a new rule, throw it in the module. And that was very easy. So I thought, well, I'll share this with everybody else because, you know, it's not gonna do any good burning a hole in my pocket, you know. So. What's that? Oh, hey. I could be wrong, but I think the CPython interpreter compiles to bytecode. Yeah, so the question is, I could be wrong, but the thing that the CPython interpreter compiles to bytecode, it might. It is bytecode, but it's their version of it's their version of bytecode. It's not machine language. Yes, and not machine language. I'm assuming that once the interpreter compiles to the bytecode, but when it's running, that actually compiles to machine language at some point. I'm not sure what point that is. So I know that when I create a Python file, I will get a CPython file popping up automatically. Same thing happens in Java. Yeah, same thing happens in Java. I've got Java bytecode, but I know that ultimately that's not, the bytecode is getting compiled into something else. Okay. Yeah. So yes, I think that is it. That is right.
Question for you?
Yeah, kind of more of a comment, kind of remind me of, which is your role is kind of expressed.
Right.
Where you would say, hey, if you see this, and do this, great job.
Yeah.
That kind of makes sense.
Yeah. The DOM is actually bigger. It's compiled, right? It's all the objects, but when you print it out, it's way bigger than the actual source code, which is the wrong direction. So I said, if I did this with XML, it would be huge, right? So I just said, well, let's just be more Pythonic and cut off that useless tail. And just yeah. Right. Right. And it generally works pretty good. The couple of hacks I had to do was that any pattern, where it just, if you have a child element, it can skip over those child elements. So. All right. So I guess that's going to wrap it up. Okay. Hey, thanks. Sorry, it's technical difficulties. Got through it. Right? Got through it.
Thanks for coming, everyone, and all in here.